Hello students in my 8th grade math class. I wanted to clarify a couple of examples that we did in class the other day. This is example 3, or it goes along with example 3 from your book, page 353, but this example is not in your book. Your directions are to determine whether the linear function is a direct variation. If so, state the constant of variation. Okay. Now, direct variation, by definition in your book on page 352, states, a direct variation is a relationship in which the ratio of y to x is a constant k. So we say that y varies directly with x. So for figuring out if this linear function is a direct variation, we already know it's going to make a line. We're going to look at y varying directly with x. So that's y over x. So you're going to take each of these values here, y, in your y column, and you're going to write them as a fraction over x. Okay? So we'll have 16 over 2. We have 32 over 4. We have 54 over 6 and 72 over 8. Okay, now you need to reduce each of those fractions. This would equal 8. This would equal 8. 6 into 54, well, that goes 9 times. And 8 into 72 goes 9. Now, when we reduce those fractions, and the ratios, we see that the ratios are not the same, while the function in the direction says that it is linear. It is not a direct variation because these ratios are not equal. If I graph them, they are going to make a line, but you will notice that that line does not pass through the origin. Okay, let's take a look at this example. This one goes along with similar to example 3 and 4 in your textbook. Again, we're looking at direct variation. Y varies directly as x. So y over x. So we're going to rewrite each of these ratios as ratios with y over x. So I would have 25.5 over 3, 51 over 6, 76.5 over 9, and 102 over 12. Okay, now we've got to calculate those rates of change. You may use your tech to do so. 25.5 divided by 3 is 8.5 over 1, or just 8.5. 51 divided by 6 is 8.5, or 8.5 over 1. 76.5 divided by 6, 76.5 divided by 9 is 8.5 over 1. And 102 divided by 12 is 8.5 over 1. Okay, now, since the ratios are the same, these ratios are the same, this is a direct variation function. That means that if you graph these ordered pairs on your coordinate plane, that this line will pass through the origin. And the constant of variation for this problem would be your constant of variation would be 8.5. Okay? Part of the problems assigned to you, you really didn't have a textbook example for this. So I am going to pull problem number 16 for you as your example problem. Now it tells you again on page 352 of your textbook that the direct variation equation is your constant of variation is y divided by x. Okay? You could also say this, that y equals your constant of variation times x. So let's take a look at what we've got here with problem number 16. And I may show you a little differently than what some of your other teachers are going to show you, but I'm going to hopefully show you a fairly easy way to do this. Now we know that y varies directly with x because it says that in your direction. If y varies directly with x, okay, now I'm reading along, you please read along with me. If y varies directly with x, write an equation for the direct variation, then find each value. Okay, so what I'm going to do with number 6, I know that y varies directly with x. Okay? It says if y is negative 12, so I'm going to stop right there and write negative 12. If y equals negative 12, when x equals 9, find y, so I don't know what y is. Y's are on top. When x equals negative 4. Okay? Then you can use your Space Invader or Jimmy Neutron and say negative 12 times negative 4, and I'm going to have to come up a little bit higher, and that is a positive 48. And then y times 9 is 9y. So we need to put equals 9y. Okay, then we divide both sides by 9, and we find out that y would equal 9 goes into 48 5 times with a remainder of 3. So 5 3/9, and that reduces to 5 1/3. Okay, now our problem says if y varies directly with x, write an equation for direct variation, then find each value. Now what we have not done is written a direct variation equation. So I will let you slide on writing that direct variation equation if you can set the problem up the way we did here. Find the cross product, solve the equation, state your answer, and reduce your answer appropriately. Okay? You're going to get the same thing if you did it the long way that they're wanting you to do. I'm just kind of taking you a shortcut, okay? So please, if you had problems with numbers 16 through 20, go back and look at it the way that I have shown you now and see if you can work those problems. Again, your assignment that you were given yesterday, page 354 through 355, numbers 1 through 20 all. If you have that completed, you will be given another practice assignment today. Thank you so much, and I will see you in class.